In previous video, we have studied properties of arithmetic mean already. In this video, we are going to cover calculation part, that is examples, and we'll try to understand that how to apply the concept of change of origin or change of scale or change of origin and scale both on the data. Then which of these concepts should be applied on data? Then what changes happen in data after changing origin or scale or both? So let's have first example. So this is the discrete type of frequency distribution, as we have studied earlier, that when frequencies are associated with individual observation, then it is the frequency distribution. So we are going to calculate the arithmetic mean for this for this discrete frequency distribution. So first we are going to calculate the arithmetic mean using direct method just to verify our answer. So let's first calculate the arithmetic mean for this data. So what is formula for arithmetic mean? Firstly, arithmetic mean is denoted by x bar. And for discrete frequency distribution, formula for arithmetic mean is summation fi xi upon summation fi. Number of observations is nothing but xi, that is marks is nothing but xi, and number of students, that is frequency. So this is nothing but fi. In order to calculate this quantity, we need to find the column first of fi into xi. So let's have a multiplication of these two columns. So what is 48 into 3? That is 144. Similarly, we are going to find this column like next is x2 into f2, that is 71 into 7, that is 497, then 890, then 693, then 208. So let's have a total of this column in order to find that summation fi into xi. So 2432. So what is the summation fi? Let's have a total of this column, that is 35. So let's make a division. So we got the answer 69.485714. So this is the arithmetic mean for this discrete frequency distribution using direct method. So let's calculate the arithmetic mean for the same data using change of origin. So let's try to understand which type should be applied, whether change of origin or change of scale or change of origin and scale both. Okay, so first let's take effect of change of origin. In effect of change of origin, we have studied the statement already that if ui is equal to xi minus h, then u bar is equal to x bar minus h. We have xi's already, that is these are the xi's. Okay, now we need to find the value of h. So how to take the value of h? You can take any value as h, but we prefer middle value or value closest to middle value for the simplification of calculation. Here we are going to take h is equal to 63, since 63 is approximately middle observation. It is approximately middle observation, not exactly middle observation. I want to make one point. If you find the middlemost observation of these values, then you got the answer in decimals. Uh, Taking the decimal value will make it difficult further. So we are going to take the value h is equal to 63, which is approximately middle value of these observations. So we are going to do the calculations further, that is ui is equal to xi minus 63. Okay, so we have done this calculation part. Now we want to find the u bar. So how to find the u bar? So what is the formula for u bar? Since this is the discrete frequency distribution, the formula for u bar will be summation fi ui upon summation fi. So we have already column of fi, we need to find the column of ui. After finding the column of ui, we can find the column of fi into ui. So what is ui? Ui is nothing but xi minus h. Ui is equal to xi minus 63. So let's have a values for ui. So 48 minus 63, that is minus 15. 71 minus 63, that is 8. Similarly 0 and 11. In order to find the summation FIUI, we are going to find that column and then we are going to make the total of summation FIUI and FI. So what is FI into UI? That is minus 45, 56, 10 into 26, that is 260, 0 and 44. This is minus 11, so minus 44. So the summation is nothing but 227. So 227 divided by 35. So we got the answer, that is 6.485714. So is this final answer? Is this arithmetic mean for the observation exercise? No, because we got the answer, that is u bar, but we want the arithmetic mean for exercise, that is we want x bar. So how can we get x bar using u bar? What is the relation between x bar and u bar? So x bar is nothing but u bar u bar plus h. I wrote this relation using this relation. So x bar is nothing but u bar plus h. So this is u bar plus h is equal to 63. So I got answer, that is 69.485714. So this is the arithmetic mean using change of origin for this discrete frequency distribution. If you verify the answer using direct method, you got the same answer. That is, using direct method you also got the value, that is 69.485714, and using change of origin method you got the same answer, that is 69.485714. In that case, why we have used change of origin only, not change of scale? Because if you see these observation, there is no any common factor by which we can divide these observation in order to reduce these numbers. So there were no any chance of simplification in calculation using change of scale. That's why we haven't used here change of scale. We have choose here only change of origin, because we try to reduce this number by subtracting any middle observation. If you remember the statement we have studied in previous video, that if some constant is subtracted from all observation, then new mean is also decreased by that constant. That is, if some constant is subtracted, here we have considered the constant as 63. Some constant is subtracted from all the observations, then new mean also decreases by 63. If you noticed here, u bar is lower by 63 than x bar. So let's have a second example. So which type of example is this? So this is the continuous type frequency distribution. Since the classes are associated with frequency, this is the continuous type frequency distribution. So let's solve this example. Since this is continuous type frequency distribution, we need to find the middle observation, that is MI, as we have seen earlier. So let's calculate the middle observation of this class. So how to find lower limit plus upper limit divided by 2, that is 0 plus 500 divided by 2, that is 250. Similarly, I am going to write all the values. So let's first try effect of change of origin. So what is formula for effect of change of origin? Ui is equal to xi minus h. In our case, it is of mi minus h. Okay. So u bar is equal to then mi minus m bar minus h. So we need to select the value of h. So you can take any value as h, but here we are going to take h is equal to 1250 since it is a middle value. We want to take a middle value because we want to minimize the calculation. Selecting the middle value resulted in more reduction of calculations. And if there is no middle value, then take any one of the middle two observations, that is middle two numbers. So here I am going to take h is equal to 1250. So let's have a column of ui. I am going to write ui here just to make the further differences. So what is the first value? That is 250 minus 1250, because ui is equal to mi minus h. So ui is equal to 250 minus this value, that is minus 1000. So what will be the next value? Then minus 500, next is 0, then 500, then next is 1000. So if you see this column of ui, you can still further minimize the number by dividing some constant. It means here we are going to apply the change of scale. We have already applied the change of origin, that is we have done the subtraction. Now we are going to apply the change of scale, because here there are the observations that can still further be minimized. There are some common factors by which we can divide the numbers and we can reduce these numbers. So I am going to choose the 500 to divide all these numbers. Let me correct one mistake. In our property, we saw that ui is equal to xi minus a upon h. There is no difference between writing any constant, but as I have mentioned this formula in the previous video, so I am making this, I am trying to make it correct. So write here a. There is no difference between writing any value, whether h or a, since we have taken this. So let's have a correction. And I am writing here mi because these are the middlemost observations of this column. So basically in that case our formula is nothing but ui is equal to mi minus a upon h. So u bar is equal to m bar minus a upon h. Okay, so we have found using mi minus a, we got this column. Now we are going to do further division, that is we are going to change the scale. So here ui is nothing but mi minus, our value of a is nothing but this, and our value of h is equal to 500. I have taken h is equal to 500 in order to simplifies the calculation. So if you found this column, then you will get the answer. If you calculate the answer, okay. So we have found the value of all ui's. Now we want to find that u bar. So u bar is equal to, what is the formula for u bar? Since this is the continuous type frequency distribution, our formula will be along with frequency, that is summation fi ui upon summation fi. So in order to find these quantities, we are going to make one more column, that is fi ui. We are going to multiply these numbers. 16 into minus 2, that is minus 32, then minus 38, 53 into 0, 40 into 1, and next is 24 into 2, that is 48. Addition of this column is nothing but 18, and addition of summation fi is nothing but 171. Okay, so what is u bar? Summation fi ui, that is 18 upon summation fi, that is 171. So after this division, we got the answer like, that is 0.105263. So we got the u bar is equal to this. So is this final answer? Again, this is not final answer, because this is the answer for u bar, but we want the answer for original observation, that is xi's. We want the x bar. So what is relation between x bar and u bar? How to find the value of x bar using u bar? So u bar is nothing but in our case it is m bar. M bar, because we have taken middlemost observation instead of x. X and m is nothing but same. So what is the value of m bar? M bar is nothing but u bar into h plus a. So m bar is nothing but u bar into, what is the value of h, that is 1250, plus what is the value of a, that is, what is the value of a, that is 500. So m bar is equal to u bar, that is 0.105263 into h, that is 500, plus a, that is 1250. So we got the answer, that is 1302.6315. So this is the final arithmetic mean for our data, that is for our observation exercise. Since this data is in classes form, we took the middlemost observation, that is mi. So our answer is in form of m bar. But no problem if you write the x bar is equal to 1302.6315. So in this video we cover the two examples in which, in that example we did only change of origin, and we have already learned that why change of scale is not suitable for this example, and in this example why change of origin and scale both are suitable for this example. We have learned. In next video we are going to learn the properties of geometric mean, harmonic mean and trim mean, and what is meaning of geometric mean, harmonic mean and trim mean. Thank you and bye-bye.